This tutorial is for educational use only. It is not authorized nor approved for any other use.
Let's start writing the DeFi Masterchef smart contract, okay? So in this video, what I'm going to be showing you, it's the way that we are going to be storing the information from the staker as well as the pools. And when we talk about the pools, if you remember on the last video, we talked about pool allocation, we talked about the total allocation, we talked about the reward percentage, and we talked about the tokens per block. Every time that a block gets processed, we are going to be generating or mining those tokens so that we can distribute the tokens onto the staking pools, okay? So in this video, we have to understand how we are going to be writing the DeFi Masterchef smart contract. We are building the Masterchef smart contract. I personally learn by disassembling things, okay? So if you want to learn about something, in my opinion, and in my case, and what has worked the best for me to grasp the knowledge and grasp all the concept and understand how everything is operating, is disassemble the whole thing. In this case, what we're doing in this entire tutorial series is that we are going to be breaking the Masterchef smart contract onto pieces. We are going to be working with the storage portion, which is going to be this video, okay? I am going to be doing a lot of whiteboarding, okay? So we want to understand how everything references and how everything connects, okay? We are going to be storing the user account, and we need to also store the time when that user account stake tokens in the contract or on the pool, which means that I have to store the block number of that wallet. At the moment that wallet staked tokens, we have to capture the wallet address and we have to reference that wallet onto the pool. With that said, I need to also tell the smart contract, by the way, the user has staked X amount of tokens so that we can do the proper math and provide the reward as we are offering in the platform, right? So in order for me to learn something and be able to master it, I have to break it apart. I have to disassemble everything and build everything in pieces. Rather than trying to learn the theory behind how something works, which is very important. I'm not saying that it's not, but in my case, the way that I learn is by disassembling everything and starting to build it, starting to fit those pieces together. You disassemble the entire puzzle and then you start assembling the puzzle back, you're going to have a very good understanding of how everything works, okay? This is what we're gonna be doing on this tutorial. So what we're doing with this video is we are building the structs, we are building the storage array, or basically the storage in the smart contract that is going to be storing the pool information. That includes the token address, and this will be the liquidity pool token, or the token that we are asking stakers to deposit, which means that the staker is going to bring that token, it's going to deposit the token into pool X, and it's going to be receiving the reward token, or in this case, the staking reward token. So what I'm going to do, I am going to, first of all, build a token smart contract. And not build, actually. I'm just going to copy and paste because this is very straightforward. If you don't understand how token smart contracts work, I will give you the link to a couple of videos that I built token smart contracts, and you can see those, okay? But this token smart contract, we have to add functionality beyond the just mint function or issuing tokens. We need to be able to control who can call to that mint function and mint tokens. In this case, that staking smart contract, it's going to talk to that token smart contract and it's going to issue the mint function, okay? So in order for us to bind those two together, we have to do access control. It's very simple, and we'll go from there. So what I ended up doing in this particular section is that I just pasted this smart contract. This is the end to the rewards token smart contract. I'm gonna go ahead and zoom in a little bit so you can see it. This will be my staking reward token. This is the token that we are going to be using to pay the stakers, okay? So with that said, it's very straightforward. Like I mentioned, it's just an ERC20 token smart contract. It has the safe ERC. It has the ERC20 burnable, which means one thing. We need to give the capability to the Masterchef smart contract to burn tokens, okay? Why? Because we need to have a deflationary mechanism. We want to make sure that we're just not inflating the token smart contract and just providing endless staking rewards, because the token value is just going to keep going down. We have to be able to incentivize the staking and also penalize the unstaking. So let's say not penalize, but provide extra rewards to those who don't on stake, okay? So if I remove X amount of tokens from a vault or from the pool, I want to burn that amount, okay? But I'm not going to burn the user's stake tokens, right? I'm going to burn the same amount of tokens that got unstaked. I am going to be burning the same amount. Why? Because that's a deflationary mechanism. Remember, I am minting new tokens, so I have to make sure that I come up with some form of control in the token inflation rate, right? We don't want to keep inflating the token, or else the token is never going to be worth more. We're going to keep lowering the value of the token. So it's kind of a messy scenario where if you stake your tokens, you're going to keep earning a lot of tokens, or you're going to keep earning rewards. But if you unstake the tokens, then not going to burn your tokens, but the supply, I have to burn it. And I have to ask for a tax fee, a fee that I'm going to be charging as a withdrawal fee or a unstaked fee, okay? Also, we have to work with the developer address. So the developer address is basically the address that the Masterchef smart contract is going to issue the fees. Okay, so every time that someone does a stake on stake, we are going to be charging a fee. That value, ladies and gentlemen, we're just gonna deposit or drop that onto the developer wallet. So this is just a normal ERC20 token smart contract, right? You know, we have a value or a private variable, like it's internal, of total supply. We're going to be storing the amount of tokens that we are minting so that we can keep a track of the total supply. With that information, then I can determine how much token do I have in circulation, how much tokens do I have in the staking pool, and every time that I raise that amount of tokens, then that value will be updated, okay? The same goes when I burn the tokens. So I have to make sure that I lower the amount, okay? And also I am going to be controlling by doing access control, right? So we are going to be adding a condition that you need to be a part of the manager role, okay? Which means that the staking smart contract, the Masterchef smart contract, is going to be assigned this manager role on the token smart contract, okay? So every time that the staking smart contract calls the token smart contract to do the mint function, I will make sure that this is. So let's go ahead. Let me do something. I'm going to show you how the logic works. Copy this. Let's head to the whiteboard. So the first thing that I'm going to do, check this out. We are going to be pasting that mint function because I want to show you what's going to happen. So this is, again, an ERC20 token smart contract function. I am going to have the following. So I have the token smart contract. So let's type this token smart contract. Perfect. And I will have the Masterchef smart contract or the staking smart contract. This will be on the right side. Okay, so the moment I decide to do the following, I'm going to show you right here. The moment a user unstakes, right? So let's say unstake, right? The moment the user unstakes, the Masterchef smart contract is going to issue the function to mint. What is going to be minting? It's going to be minting the reward amount. Okay, so it's going to be issuing the mint function, right? It's going to be calling my token smart contract, and it's going to say, hey, by the way, I have X amount of tokens. Please provide me that amount, and then send that amount. Is going to be sending that amount to who? To the staker, okay? So the staker is going to receive that amount of tokens, okay? So the moment I issue that amount, right? And then the DeFi Masterchef talks to the token smart contract, sends the request to mint the tokens, sends that amount to the staker's wallet. I am going to be issuing another call to burn those tokens, but not burn the staker's tokens. Absolutely not. We're not going to do that. What we are going to be burning is going to be that amount of tokens. We will also burn those tokens, okay? Which means that what I'm doing is a mechanism to deflate the token. So we control somehow the amount of tokens that we are generating versus the amount of tokens that we are, issuing, right? We want to build that function in the DeFi Masterchef smart contract that is going to do both things. It's going to mint and it's also going to be burning. That will be sequential. That will be basically mint and then just call burn, okay? So what we do is we set that in the smart contract, and every time the user unstakes, we are going to be doing those two functions or those two actions, okay? which means that I have to make sure that the manager role, let me go ahead and clean this up a little bit. So the manager role, right? This role right here, I have to make sure that I add the DeFi Masterchef smart contract as part of this role in the token smart contract, or else I am not going to be able to issue mint requests, or the DeFi Masterchef contract is not going to be able to mint those tokens, okay? Once we're done with all this, let me just delete all this. So once I'm done with that, I have to make sure that my total supply either goes up or goes down, okay? When it's going to go up, when it's going to go down. It's going to go up every time we call that mint function, okay? And it's going to go down every time we burn the tokens, which means that I have to grab total amount, right, of tokens minted during that action, right? That's step one. How much, previous total amount we mint, and then we are just going to grab that previous amount, and then we are going to be at the amount of new token minted, okay? So we are building that functionality. So then the moment we mint new tokens, we increment this total supply. The same goes with the burn. Every time that we burn tokens, we are going to be decreasing that total supply by subtracting what I had as previous, right, with the burn amount, okay? Cool. And there you go. Awesome. Let's continue. We are good with the N2D rewards token smart contract, right? I need to do is build that staking smart contract, or the Masterchef contract, okay? So let's start by building the contract by importing what we need, okay? So let me show you. Okay, so the first thing that I'm going to be doing is I am going to import the interface to interact with the token smart contract, which in this case is going to be the IERC20. Okay, so we are going to be working with IERC20 that it allows me to interact with the token smart contract, do transfers and all that. We also have to make sure that we import the safe ERC20. We also have to add some security for re-entrancy guard and also the ownable role, okay? And finally, we are going to be importing the N2D rewards token smart contract that we previously built. It's very straightforward. That's it. That's all we have, okay? What we need to do, we are starting by initializing this contract. We're gonna call this contract N2D Masterchef version 1, okay? Okay, we are going to say it's ownable and it's re-entrancy guard. So we have initialized the contract. So now what I have to do is the following. We are going to be importing the safe ERC20, okay? And also safe math, because we want to make sure that we don't have some overflow going with our integers, okay? So we are going to be using safe math for UINT 256, okay? So this is how we implement safe math. And now we are going to be using the safe ERC20 for IERC20, right? Now we have this, now we can build the structs, okay? So we are building two structs. The first struct that I'm going to be building is the UserInfo. That is the struct that is going to store the amount pending reward, okay? What is the pending reward? It's basically how many tokens is the user holding as reward pending in the contract, okay? So in the function, every time the user interacts with the smart contract or the pool, we have to generate that reward, okay? So we have to be building that reward. And the beauty of it is that every time someone calls the smart contract and interacts with the pool, we are going to be updating the pending reward for everyone, okay? So which means that user 1, user 2, user 3 will all have the updated pending reward, okay? If I call that function, I am going to take advantage of that call and update the pending reward across the pool. I have to store the amount of tokens that the user has staked and the reward that is pending to be paid to the user, okay? Then I am going to be storing the pool information. So every time that we create a new pool, meaning that I'm going to be incentivizing users to stake tokens into this DeFi staking pool, I have to store the contract address so then we can interact with that token smart contract. I will be storing what? Okay, so let's check this out. Let's build the first one, struct, and we're going to call this a UserInfo, okay? And now we are going to be storing two attributes. We're going to be storing UINT 256, and we are going to call this amount, and the other attribute is going to be UINT 256. It's going to be pending reward, okay? So that will be the amount of tokens that I should be issuing to that staker, okay? This will be the struct that is going to store all the pools created in the DeFi Masterchef contract, okay? So we're going to call this PoolInfo. So the first thing that I have to be storing, it's going to be what? It's going to be the token smart contract, okay? So this is not the reward token smart contract. This is the token that I'm going to be incentivizing to stake, or this will be the pool token that I'm asking to users to stake so that they can earn the rewards, okay? I have to invoke the IRC20, that's the interface, so then we can interact with that token smart contract, and we are just going to call this LP token, okay? So this will be the liquidity pool token. And let me do camel case here, token, okay? Next item that I have to make sure that I store in the pool information, and that is the allocation point, okay? Alloc point, okay? What is the allocation point? If you remember on the previous video, we mentioned the allocation point. It's that percentage in basis point of how many tokens from the amount of tokens that I'm going to be mining per block, we are going to be offering to pool 0, pool 1, pool 2, pool 3. I am going to be offering 30% to pool 0, which is, in this case, is the first pool. The second pool, pool 1, it's going to obtain 40% of the total amount of 9 tokens. That is the allocation. Now, very important, UINT 256, what am I going to be storing? Token last reward block, okay? That is the last block that we read that we got tokens mined and also unstaked, okay? So I, as a user, decided to unstake on block number 49,600. In the pool information, that will be the last reward block. The moment I unstake the tokens, that will be the last reward block. That's the last block that I interacted with and I got rewards, okay? So this will be the last block, okay? Another item is going to be what? It's going to be the actual reward. 256 is going to be reward token per share. And if you remember in the first video, this is the amount of reward tokens that I'm going to be issuing to the staker per token staked. I, as a user, stake 10 tokens, and I'm saying with the reward token per share, once I store the amount or the value here, let's say I'm going to be paying 5 tokens per each stake token. I stake 10 tokens, 5 tokens per stake token, 5 tokens times 10, I will be receiving 50 reward tokens, okay? So this is the amount that I'm going to be paying as a reward for each stake token, okay? Beautiful. We are done with the pool info. We have all the information, and now we can work with the storage piece so that we can properly allocate this onto the pool, okay? So for that, we have to go back onto the whiteboard, and we are going to be breaking this entire logic, okay? So check this out. So you can see right here that I have both structs. So let's talk about the logic, what's happening right here. We mentioned that when a user decides to stake, we need to grab the address of that wallet. Okay, so we are grabbing the address, and that's how I'm going to be able to reference the amount of tokens that the user has staked, okay? Which means that I have to do a mapping that is going to associate the address of the staker to this particular struct. And there I can reference the amount and the pending reward. Now, here's the thing. When I stake tokens, that amount, ladies and gentlemen, will be used by the pool information to determine how many tokens am I going to be issuing to that staker. Which means that if I have an amount of, let's say, like I mentioned, 10 tokens, I decided I, as a user, right here, so it looks better. Okay, so the wallet address, it's going to be the information that we are going to be referencing to the struct. So I, as a user, decided to stake 10 tokens, and the reward token per share, I, as the developer, has set this value to be 5, right? If I am the only one staking in this particular pool, I am going to be obtaining 10 times 5, it's going to be 50. So I have to grab that amount, right? And we have to make sure that we obtain that information for that particular user, which means that I need to determine the amount of token wallet X has staked on pool number 1, okay? So for that, I need to be able to reference the information from the user side, right? Or in this case, the wallet to the pool. So let's say I stake 10,000 tokens, right? So let's say we stake 10,000 tokens. We have to grab this value and we have to reference that value to the pool ID, okay? Or in this case, it's going to be the pool number that I staked those tokens, okay? I am going to be grabbing that value and then I'm going to be determining how much reward tokens am I going to be issuing to that user. So in this case, for those 10,000, I need to determine the reward token per share, okay? So I'm going to grab that amount and we are going to be multiplying by the reward token per share. Okay, so we are going to be multiplying that amount and then we should be able to obtain the amount. However, again, we have to understand that this is not the only user that is going to be staking tokens. Okay, we are going to be having more users on this pool. Okay, so for that, don't worry, we're going to build the information struct. We're going to build the storage and we're going to test. We're going to store some pool IDs and grab some token addresses. We'll add those and then you can see how can we store into the smart contract and then we'll do the math on the next video, okay? So now I have to reference that wallet address to the user info struct, okay? So let's do that. We have to determine the following. We need to know to which pool did the user stake. I have to map the wallet address and I have to map also the pool ID. How do we do that? Check this out. We are going to be building a nested mapping. Let me go back onto the whiteboard. I'm going to do it real quick. So what we're doing in this particular mapping is that I have to reference the user struct to the pool struct. Imagine this scenario. I decided to stake 10,000 tokens to the USDT pool, which is pool ID number 1. This will be the second pool. So I staked 10,000 USDT onto pool 1. So in order for me to reference that I staked 10,000 tokens onto pool number 1, I have to do a nested mapping. What we are doing is the following. We are going to be mapping UINT 256. Okay, check this out. UINT 256, that's the number. This allows me to map the number to this particular struct. With that number, okay, now I know that I'm interacting with pool number 1. What am I going to obtain as information from pool number 1? I want to obtain how much wallet X staked on that pool. Okay, so now I have to map that to another mapping. So I have to nest this onto another mapping. So let me just go ahead and delete this. So now we are going to be mapping 256. We're going to open here, right? And now we are going to be mapping. So check this out. We're going to be mapping UINT will be mapped to where? To mapping again. Now we are going to be mapping it to address. That will be the wallet address. Now I am going to be mapping the wallet address. Okay, I'm going to be mapping that wallet address finally to where? To the struct UserInfo, which means that I am going to do this. Okay, the first thing that I have to talk or I have to call or I have to provide onto the smart contract, it's going to be the pool ID. Reference the pool ID. I got to tell the smart contract, hey, for pool ID number 1, so we're going to be passing pool ID number 1, right? I want to also pass you this wallet address. And we mentioned XXXXX. That's the wallet address of that user. Now I effectively landed onto the struct itself. And now what I can do, I can call amount, and I should be able to obtain how many tokens did that user stake on pool number 1. Okay, so now I know how much tokens is the user taking on that pool. Okay, so this is how we do the nested mapping. We're mapping onto mapping. So we're mapping the pool ID, right? So this is the first thing, pool ID, right? Mapped to the address. So we have to call pool number 1, then we provide the address of the wallet, and we have officially landed in the user information. In this case, this particular struct, we can call amount and we can call pending reward. Okay, and then I can obtain how much tokens do I have to provide to that user. Beautiful, awesome. So we have to build this mapping. Okay, And this mapping, we have to call this public because we're going to be interacting from the user perspective. We're going to be interacting with that, okay? Which means that it's going to be declared as public, and we are just going to call this UserInfo, okay? There you go. So that will be the way that we are going to be mapping the information for that particular user. So let me go ahead and delete this. Now we have to work with the PoolInfo. We can do it this way, or we will use the storage as it's configured on the Masterchef. We're storing all the information in that storage. Is more cost. So there's more cost to it if you store it into an array than just calling mappings to do that, okay? But let's do it that way. So we have pool information, and we want to make sure that anytime that I need to interact with a particular pool ID, I call the pool ID number 1. So in this case, I decided to call pool information, and I pass the number 1. I should be able to read the information for pool number 1. Okay, we got the user information. Now we need to make sure that we reference the pool information. For that, it's going to be a little bit simpler. All we have to do is that we are going to call this PoolInfo, right? We're just going to open and close that array. And then we are going to call this public PoolInfo, okay? Which means that anything that I'm passing inside here as the pool ID, I can call individual items, okay? And you're going to see that. Don't worry. Okay, so let's go ahead and add that to the smart contract. Okay, so we're going to be calling mapping, and we are going to say, let me just put it over here. Let me expand a little bit more. Okay, awesome. It's going to be mapping UINT256. This will be the ID of the pool, right? And we are going to be mapping that to another mapping. We're going to do a nested mapping. Inside the nested mapping, we're going to be mapping that to the user wallet. Okay, so whoever staked, that's how we're going to be referenced to the address. So then we can ultimately land in the UserInfo Struct. And that will give us all that information. Okay, awesome. Then we'll do public. We're going to declare this public because we know that we have to interact with it. And that's it. Awesome. Now we are going to be doing the PoolInfo. So this will be a storage. We're just going to do the storage array here. It's just going to be PoolInfo. And now declare this to be public, and we're going to call this PoolInfo as well. Beautiful. So we got both now. Okay, awesome. Now, the next thing that we are going to work with is going to be the variables that we have to create and declare in the smart contract that will be used across the entire functions. Okay, all the functions. Let's work on that. Okay, now we are going to declare the first one. The first one, it's going to be the name of the staking rewards token smart contract, which in this case is going to be the end-to-the rewards, okay? So which means that I have to be passing to my Masterchef contract the name of my token smart contract. We're gonna copy that, okay? Copy that right here. And then we're heading into the staking smart contract, and we're going to be invoking that name. And let's call this N2the R, okay? This will be the declaration, okay? And we have to make sure that we do this to be public, okay? So that we can access it from outside. Now we have to store also the developer's wallet address, okay? What I'm going to do, address public, and we're just gonna call this dev, okay? So that we can pay the developer every time that someone does the unstake. We'll receive the fees onto that wallet, okay, the percentage. Finally, we are going to be storing, this is very important, UINT256 public, the N2VR per block, okay? This, ladies and gentlemen, this is the amount of tokens that the Masterchef smart contract is going to issue or is going to mine every time a block gets processed. And this will not happen for all my pools. This is going to happen globally, and then every pool is going to have that allocation. We're going to be separating the amount of tokens for pool 1, 2, 3, and such. Okay, we're going to be distributing those pools. Now, the next thing that I'm going to be declaring publicly is going to be the following. We're going to be declaring the total allocation point. So we're going to be declaring another public, and this will be the total allocation. And this is the total of pool allocation combined. So every pool allocation is going to have 1%. The total amount of those, it's the total allocation, okay? And by the way, we are going to be initializing this with 0. And you are going to see that this is going to change as we add more pools onto the staking smart contract, okay? Next, what I'm going to be doing, we want to also specify the block that we are going to start mining those tokens or generating those tokens. Okay, so the moment we deploy the smart contract, we can determine when is the token emission going to start. Okay, so we're gonna say start block. Okay, and then when we deploy the smart contract, we're gonna provide the block number that we want to start generating those tokens. Okay, and it's not going to mine, it's not gonna mint the tokens, it's just going to start counting how many tokens it has to mint. Okay, which means it saves on gas fee. It's not going to be minting tokens every 2 seconds. Every block gets processed, we're gonna be minting because that's just gonna be exponentially expensive. So we're not gonna do that. And this will be the bonus multiplier. Okay. We're gonna call this bonus multiplier, okay? This is the amount that I'm willing to increment. So if I decided to do an x2, that will mean that the amount of tokens that I'm going to be issuing as rewards, it's going to be double, okay? Beautiful, we are very good now. Now let's build a constructor, okay? I'm gonna go fast and then we're gonna test. Okay, so we're gonna do constructor and we're gonna build that constructor. Inside the constructor, let's start declaring the information. Okay, the first thing I'm gonna do, I'm gonna say into the rewards. Okay, this is how we are going to initialize that contract into the staking smart contract. Once we deploy the smart contract, we're gonna be asking for the token smart contract address, okay? Into the R. Okay, now we're gonna do address, and this will be what? The developer address. We need to pass that value, so then once we deploy the smart contract, it gets stored, okay? Now we are going to pass UINT to 56, and we are going to say into the R per block. This is when we tell the smart contract, hey, you're going to be minting 10 tokens every block gets processed. Let's say, for example, okay? Then we are going to be passing UINT to 56, and this will be what? The start block, okay? This will be the moment, the block that it's going to trigger this smart contract to start issuing those tokens, to start mining those tokens. Finally, UINT to 56, and we're gonna say multiplier, because we wanna make sure that we specify how much is the multiplier reward, or this will be the bonus multiplier. This is how we're going to be issuing that. We're going to call this public, right? Because we want to make sure that this is declared publicly. And now we are going to be providing the values that we are going to be storing, or where are we going to be referencing those values. In this case, the n to the r will be referenced to the variable, okay? So then we can reference everything. Remember those public variables? Now we're going to be passing what values are they going to have. So the first one is the n to the r. So I'm going to just copy this. I'm going to paste it right here, and we're going to say n to the r, it's equals to underscore n to the r, whatever I pass when I deploy the smart contract. The same is going to go with def. It's going to be def. Now it's going to be n to the r per block equals to underscore n to, you see what I'm going, per block. And we do the same thing, start block and start block. Beautiful. Finally, multiplier. But this will not be multiplier. This is going to be bonus multiplier, okay? So let's pass that. So bonus multiplier, copy, and I want to pass it here. And now we are going to be passing that to multiplier. Beautiful. Okay, one last thing and we're done with the first part. What I'm going to do now, I am going to initialize the first pool. The first pool is going to be the n to the r reward pool. And this is a typo right here. I'm going to fix that. There we go. Beautiful. Okay, awesome. So let's build that first pool. Advantage of doing this. This is how we are going to store this information. This is the pool information. This is what is expected to be provided, okay? And if you know in JavaScript, this is the way that we store this in the array is we push, right? Which means that I have to call the public name or the public mapping to the storage and then push the information inside, okay? So check this out. I'm gonna say the following. I'm gonna say PoolInfo push, just like JavaScript, okay? Inside here, I am going to be pushing what? Check this out. I'm going to take advantage of this. I'm going to copy the entire struct because that's what's expecting. I'm gonna copy that. I'm gonna paste it right inside here, okay? And I don't need to have the type. I just need to have the variable because I already declare that in the struct, right? So I don't need to declare it here. We're just going to be taking the opportunity to store the information inside here. And we have to now pass the actual struct name right here. This is the mapping, but now we are passing the actual struct name inside here. Okay, and now inside here is where we do that magic. Okay, we are going to be providing those values. Okay, so in this case, the liquidity pool token, it's going to be the address of the end to the R token smart contract. Okay, the allocation point, it's going to be the amount of tokens that I'm going to be providing as the allocation for pool number 0 in this case. So if I mint 49,000 tokens in 24 hours, and I say that I'm going to be allocating 20% of that amount, that will be the allocation. That's how many tokens am I going to be providing to that pool so that it can be distributed to the stakers, okay? Last reward block, we want to make sure that we store what was the last block, okay? The last block that we did an action or did an activity in that pool. And the reward token per share, this is the amount of tokens that I'm going to be offering as the reward. So let's say I stake 1 token, I am going to obtain 3 tokens. That will be the reward token per share, okay? Okay, so the first thing that I'm going to be passing, remember, is the end to the R, because we're going to be passing that to store that on the smart contract. Might as well pass it here as well, okay? Beautiful. By the way, it's not going to be equals. So this will be LP token. This will be allocation point here and here, okay? Beautiful. So now I am passing the address that I'm going to be passing once I deploy the smart contract. Now allocation point, I am going to be offering 10,000, which is like 10%. Okay, we're just going to provide that. And you're going to see that we can modify this to provide even more or less. We can modify the pool. Okay, and now this is 10,000. This is like 10%. Last reward block, because this will be the first pool, I am going to be passing start block as the value. Okay, so we are going to be passing the start block as the value that will be the last block. And then that will be updated because every time that I'm going to be on staking, this will change. And then I'm going to say that reward token per share, in this case, is going to be 0 because this is the amount of tokens that I will be distributing based on the amount that I have staked. Don't worry, you're going to see this once it starts generating the tokens. You should be able to see that amount increment. I don't know how many tokens am I going to be offering if I don't know the amount that is staked. You know what I'm going with this, right? If the moment I stake tokens, then I should be able to understand how many tokens am I going to be distributing. Beautiful. So now the last thing I want to do is I want to declare outside of here, total allocation is going to be what? Since the only thing that I declared as a pool is just this pool, this will be the total. This will be 10,000 as well. Because pool, there's only one pool. That will be the amount of total allocation, okay? And that's about it. Yep, that's about it. Awesome. So let me go ahead and copy this. Let's go to Remix it. Let's deploy it and let's see how that goes. Okay. And let me grab this. Let me copy. Go ahead and paste. Okay, let's take a look at that. So I have this and total allocation. There seems to be a syntax issue here and here. Okay, that should do it. And we can see the entire information that I'm going to be passing, okay? Alrighty, awesome. So the first thing I'm gonna do, I'm gonna deploy the end to the rewards token smart contract because I need the address so that I can deploy the Masterchef smart contract, okay? So let me go to the end to the rewards. Let me Control S. Okay, beautiful. Let me make sure that the Masterchef smart contract is also good. Control S, beautiful. Okay, let me bring my wallet and we're gonna be interacting with the Sepolia testnet, okay? Beautiful. Let's start by deploying the token smart contract. Beautiful. Let me select injector provider, Sepolia. Let's deploy. Here he goes and confirm. Okay, so we got the token smart contract. Beautiful. Okay, awesome. Now let's deploy the Masterchef smart contract. And remember, this is all the way to what we done just to store and show you how the storage works, okay? Okay, now let's select the Masterchef. Here it goes. And let's see what it's asking. Okay, so remember when we declared this under the constructor, let me zoom in, right? we now can see that N to the R is what I'm asking here. This is the token smart contract that we just deployed, okay? So I'm gonna add that here. Now the developer address, and guess who's gonna be? It's gonna be me, okay? So I'm just gonna copy my wallet address. This will be the developer address. Now I'm going to determine how many tokens am I going to be minting per block or generating per block. In this case, I am going to be generating 10 tokens per block, okay? So in this case, I'm gonna add that value in way. Let me just get the formula real quick. I'm gonna say, and I'm gonna copy this, and I'm gonna paste it right here, beautiful. Start block, okay. So because we're interacting with this Polia testnet, let's find what's the latest block, okay? Let's find that information. And the last block, it's going to be 417554, okay? So let's copy that value, just paste it right here. And the multiplier, okay? So in this case, I don't want to modify, and again, we're not gonna do any math. All I'm gonna be passing is just one, okay? Now we should be good, okay? So we're going to deploy, and this will be the contract deployment. Awesome, we're done with that. Now we're just going to see that we have effectively deployed the first pool. We should be able to see that there. Okay, so we got the Masterchef smart contract deployed, and let's take a look and see what we got, okay? And you can see there's not too much because again, I haven't built any functions, just the storage. Now let's take a look at the PoolInfo 0. Remember, that's the pool that we just built right here, okay? So we're gonna say PoolInfo 0, and there you go. The liquidity pool token, it's going to be the N to the reward, the token smart contract that we just deployed. I am going to be allocating 10,000 basis points, and this will be the percentage of tokens for pool number 0. And the start block, remember, we provided that as the value. It's going to be passed as last reward block. And reward token per share, again, I don't know how much it is because no one has staked. So once we stake, then we should be able to determine how many reward tokens are we going to be distributed to all the stakers, okay? All right, so we're done with part 1. We got all the storage built. We now stored pooled information. We stored the user information. And by the way, I don't have anything because I haven't staked, right? So in this case, if I go to UserInfo, and by the way, this will be the pool ID. So in this case, it's pool 0. This is the only one. If I pass my wallet, I am not going to, and I can just grab this address. This is the same. I'm not going to have anything because I haven't staked, right? So I'm not going to get any information, but you can see here that once I pass, remember that nested mapping that we did? This right here is literally what has been passed here, okay? So I'm passing the pool ID, that's going to be the first parameter, and then the address. And now I obtain the information inside the pool UserInfo struct, okay? The amount of tokens and what is pending to be awarded to this user, okay? All right, so let's cut it here. We're done with part 1. We did all the storage. On the next video, we are going to start working with the math. Alrighty, that's it for video number 2. Let's continue on to video number 3.